So 6.2 was due already today, right? Moments ago. 6.2 was due. And we're off. The plan today is to finish 6.3 and 6.4, which is all this. Man, we're all ready for another exam, aren't we? They just keep coming fast. So it feels like we just had one, but I guess not. Guess it's been a couple weeks.
No, you were just going to push one on us today.
Well, yeah, it was supposed to be Wednesday. I'm pushing it off. Yeah, did I already say, or I'll just write on this thing here. Did I already say that yes, did I mention oh no, I didn't mention anything. Let me talk. I'm pushing things off one day. We're behind a little bit. So the practice exam will be Wednesday, because it was supposed to be today, right? And the real exam was supposed to be Wednesday. It won't be. The real exam, number 3, is next Monday. We'll put it off Monday, what is that, the 16th? Yeah, Monday 10/16. So we'll push everything back one day from the schedule, what it says on the schedule. Does that sound good? So practice exam in 2 days, real exam next Monday, week from today. And the exam 3 covers up to 6.4, so we'll finish that stuff, I hope, today. It goes up to, where does it start? 5. Says it on your handout. 5.1, I guess. Okay. So 5.1 all the way to 6.4. That's what it covers. That was a long time ago. I think we did, but it was a long time ago. So 5.1 all the way to 6.4. That is exam 3. So again, practice exam Wednesday, real exam next Monday. Okay, so let's finish 6.3, 6.4 today. So we'll finish all the material, and you'll have a week to get ready. I mean, I got to move on with new stuff, but you'll have a week to digest this stuff. Square root of 20. Now, you can hit the buttons on your calculator and get a decimal thing, but they don't want a decimal on this one. They want a simplified root kind of answer. Have you seen this before, how you would give a simplified root answer when it's not a clean one? You know, it's not like square root of 9, which is just 3, or square root of 16, which is just 4.
Don't you factor the 20?
Yeah. Have you seen this? If you took Math 201, probably you've seen this. You break it down. What times what is 20?
5 times 4.
5 times 4, 2 times 10. Do whatever you want. All the different ways to do it. If you use calculator, if you're rusty on some of these. What times what is 10? 2 times 5. And that's as far as I can go, huh? Because those are all primes. You know what I mean? 2, 2, and 5 are numbers that don't break down anymore. They're primes, right? So what? Okay, well, that means the square root of 20 now is the square root of 2 times 2 times 5. That is a 20. That's the guts of a 20, if you will. That's the innards of a 20. We're like in biology class, and we just cut open the frog to see his innards. So there's the innards. Sorry, it's lunchtime, giving you some images there. So there's the 20 broken apart, right? That's the guts of the 20. And now, yeah, what's the deal? 2 2's in, ship 1 2 out, and they're gone. It's a 2-for-1 deal. 2 2's inside the square root, ship 1 2 outside the square root. That's the fundamental root action. It's like going to Target. Things are on sale 2 for 1. You buy 2, go out of the store paying for 1. That's what happens. So 1 2 comes to the outside. The other 2's are gone. And what's left on the inside? Just the 5. And that's the answer, 2 root 5. So it's a 2-for-1 deal. 2 2's inside the root leads to only 1 2 outside the root. 2 for 1. Now, why does it do that? Are you thinking that? Carrie, you're thinking that, huh? No, you're just thinking, I just want to get the rules done. But really, I mean, isn't that weird? Why does it do 2 for 1? Is that a new rule? Actually, no. I mean, I haven't said it that way, but it's what we've been doing all along. Think about square root of 9. What is the square root of 9? 3. You all know it's 3. It just happened right there. I didn't say it and call it out and do target and all that. But what is in a 9? What is a 9? 2 3's, and how many 3's came out? That's what we do all along. That's what we've been doing all along. That's what square roots do, because they ask, what times itself twice is this thing? That's like saying 2 for 1. That's what that is. That's what square roots always do. It's nothing new. Just haven't called it out that way before. So 2 2's in, 1 2 out. And they both disappear. Right, just like right here. Both the 3's vanished, only 1 3 came out, huh? That's the deal.
When we get into logarithms, what?
Now we have a 3 in the hook there, the Scooby-Doo hook. So what do you think is going to happen here? Let's break down the 40. What times what's 40? 4 times 10, 5 times 8. You can do whatever you want. You know it'll all come out the same in the end. It doesn't matter how you break it down. That's actually the fundamental theorem of arithmetic. Anyway, you're not going to be tested on that. But it basically says that there's only one unique DNA for every number in primes. There's only one way. It'll break down the same however you do it. So 2, 2, 2, 5. So I have the cube root, the third root of 2 times 2 times 2 times 5. 3 2s and a 5.
So the 3 dictates if 3 are on the inside, 1 comes out.
Exactly. So you're going to target, and it's a 3 for 1 deal. Yeah, whatever number's in the hook, that's the deal at target. So you're going to target. Things are on sale 3 for 1. So 3 2s inside leads 1 2 outside, and they're all gone. Where they all vanish. So 1 2 to the outside. What's left on the inside? Just the 5. And you got to keep the 3 in the hook. That'll like always be there because that's the deal. It doesn't change. There's our answer.
Tag on.
What?
You have to leave the price tag on.
Yeah, however you want to do that analogy. 3's got to stay. Yeah.
The example I have here factors into like 7 numbers.
Yeah, sometimes they get big.
Yeah, so like what do I do with that?
We'll get there.
Okay. Well, it's the same problem though.
Is it?
Yeah, it's number 2 and I got the cube root of 270.
Wow, you got a rough one.
Yeah,
I would, you know what you do there? You roll the dice again. You say no, no, no 3 times, and then you ask for a new one.
Okay.
No, I mean, I'll do it. I'm just joking around. I'll do it. But you do want to learn how to play the Math Excel game a little bit. All right, so 270, yeah, let's break down 270. Anything that ends in a 0, I like to just say it's times 10. I mean, you don't have to, but I think it's pretty easy way to go. So 27 times 10. Okay, and then break down the 27, 3 times 9. Break down the 9, 3 times 3. The 10, 2 times 5. Good to there so far?
Yeah.
And I'm only using all the bottom, the prime numbers. So what do we have? Cube root of 3, 3, 3, 2, 5. Good so far? Because that's 27 times 10. That's 270, isn't it? It's the guts of a 270.
I have 4 3s.
Well, you messed up.
I have 9. Oh yeah, no, that's 3 3s. You're right. Sorry, 3 3s.
Okay, and now 3 3s in
Okay.
is 1 3 out. Right, 3 for 1 deal, and their ones on the inside are all gone. So 1 3 to the outside. What's left on the inside? 2 times 5. They just remultiply when they can't come out. They just remultiply.
Right. Okay.
Yeah, so that was a little more stuff.
Trying to get a prime number in there was the issue. So, all right.
Yeah, just remultiply them on the inside when they're left over.
Okay, so you're just looking for the common like cube square thing in there.
Yep. Yeah, you just whatever there's 3 of, ship 1 out. One of the only times in math where the letters are easier than the numbers. Because there's no mystery. You know exactly what it is. Whereas 32, we're not sure exactly what's in there. But x to the 8th, well, that's 8 x's. No mystery there, right?
Oh, so you factor the variables also.
We'll see. So let's break down that 32. So go ahead and break that 32 all apart. Break it down to its prime factorization, it's called. So what times what's 32? 4 times 8. And 4 is 2 times 2. 8 is 2 times 4.
Which is 2 times 2.
And that is 2 times 2. So we break down the 32 and we get 5 2s altogether, right? We good?
So 3 dictates that 3 is number 9.
So we get the cube root of 2, 2, 2, 2, 2, 5 2s. And then what's x to the 8th? Yeah, 8x's, right? Now, I'm going to write them all out this time. but then I'll show you a shortcut after that. But it's good to do it once. I mean, if you never, it doesn't take that long. Boom, there, I'm done. 8x's, so 5 2's 8x's. And now, what's the deal at target? We got a 3 in the hook. It's a 3 for 1 deal. So what does that mean? Anytime you find a group of 3, you send one representative of that group out, and that whole group is gone from the inside. So 3 2's, I mean, sends out a 2, and they're gone. The other 2 2's have to stay inside, and they'll make a 4. They remultiply to make a 4, because there's not 3 of them. Right? You got to have 3. That's the rule. When there's 3 in the hook, you've got to have 3 whatevers to ship 1 representative out. If you don't have 3, they just stay in. Now, how about the x's? 3 x's, ship out an x. 3 x's, ship out an x. The other 2, they're staying in. They're staying in because there's not 3 of them. Okay, so what makes it to the outside? Am I racing ahead of you? What makes it out there? 2xx, which is 2x squared. Exactly. We good? A single 2 and 2 x's. Right? 1 x representing this group, 1 x representing that group, and a single 2 representing that group. Made it to the outside. What's left over in our cube root? Keep the 3 in the hook. It's all, you never change the hook number. It's always the same.
4.
What's left inside? Yeah. 2 times 2, whatever's left over. 2 times 2, 4, and x times x, x squared. That's the answer. So whatever can come out, does come out. Whatever there's 3 of, ships 1 representative out. Whatever's left over stays in. So 2x squared, cube root of 4x squared. Questions on that? That good? All right. All right, try that one. 4 through to 160. So break down that 160. It's got a 0 on the end, so that's going to be 16 times 10, right? Is it one good way to go? 16 times 10, and then keep going from there. So 16 times 10. Sixteen is 4 times 4. Use your calculator if you're rusty on some of these. Good to there. Break it all down. So this is the 4 through the 2, 2, 2, 2. So 5 2's and a 5 inside. Did you get all that when you break it all down?
Yeah.
5 2's and a 5. All right, and it's a 4 for 1 deal. 4 2's. Send 1 representative out, and they're gone. So what's left on the inside?
10.
2 times 5, 10. There it is.
Would you say to the 4th root? How would you say that?
Just like that. 2 4 through to 10.
4
2
through
2 4 through to 10. Is that good? Is that making sense?
Yes.
Questions on that? All right, we'll keep moving.
Well, it's just going to be the number of exponents divided by the number indicated, correct? 12 divided by 4.
Right, exactly. Okay, so 80 x to the 12th. So 4th root of 80 x to the 12th y to the 14th. Yeah, let me move it up. I need a little more room. So bring it up here. So 4th root of 80 x to the 12th y to the 14th. Okay, yeah, the 80 is just normal, just break down the 80. 8 times 10, right? Anything ends in a 0 is times 10. Keep going. 2 times 4, 2 times 5, 2 times 2. Okay. All right. So we have bunch of twos, don't we? So you could just circle them if you want. Look, there's 4 twos. So it's going to ship 1 2 outside, isn't it? We good so far? What's left on the inside? Well, just the numbers first. Just the 5, right? So 4 through to 5. Yeah, now let's do the X's and Y's. But so far, so good? You okay with the numbers, I mean? I'll get to the letters in a second. Everybody okay with the numbers? I broke that 80 down. 4 2s and a 5. The 4 2s sent 1 2 to the outside. Okay, now, let's do the X's and the Y's in a way that's a little quicker. You could write all the, let me write all the X's one more time. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 X's, and you're sending out groups of 4. So if you're going to buy 12 items at Target, and they say, hey, things are on sale today, 4 for 1. This Christmas at Target,
Yeah.
right? 12 items on sale, 4 for 1. That's the day after Christmas. So how many are you going to pay for? If you buy 12 items and they're on sale 4 for 1, how many are you going to pay for?
3 credit card.
3 to get out the store, right? Because these 4 will be 1x, these 4 will be another, and these 4. So what are we just doing? We're just dividing by 4, aren't we? That's what you would do. And that's all you got to do is divide by the power, huh? Right? So what comes to the outside is 2x cubed. Now what about the y's? Let's do the y's. Because they don't divide by 3. You can't divide 14 by 3, not cleanly anyway.
You're going to go outside and then...
Yeah, so we have to say, how many times does 4 go into 14? How many groups of 4 are there? 3 groups of 4 would be 12 with 2 left over, right? 3 times 4 is 12. 2 left over, remainder. So that means in 14 y's, and then let me just write them out for extra clarity, but you don't need to. 14 was 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. In 14 y's, there's 3 groups of 4 with 2 left over, aren't there? That's what this is saying. 3 groups of 4 with 2 left over. So that means how many come out? 1 from this group, 1 from that group, 1 from that group, y cubed. And how many are left over inside? Y squared. Does that make sense? So you don't have to write all those x's and y's out. You can just divide by the power. Divide for letters. Divide by the, well, it's not a power, by the number in the root. Right? Divide by the 4. That makes sense? And whatever remains inside. So for the y's, you would just say, look, 14, and I'm just going to divide by, I'm going to take the 14 here, and I'm just going to say 14, divide by the 4, and that goes in 3 times, 2 remain inside. 3 groups come out, and 2 remain inside. Everybody good with that? Mm-hmm. Mm-hmm. No questions? We good? I don't know if you guys are just sharp today, it's all good and easy, or you're just not interested. Trying to make sure. But you look interested, so I think it's... Let's see. So square root of 3, square root of 21. There's nothing in the middle, so what does that mean really in the middle? It's times. Yeah, it must be times. Okay. Now you could multiply those and get whatever that would be, root of 63. But that wouldn't be helpful. I mean, if I did that, if I multiplied those, don't write this down, don't do this. If you multiplied those and got root of 63, it's not wrong, it's okay, but it's not helpful, because then what would you need to do with the 63 right away? You'd have to start breaking it down. Well, if that's the case, why don't you just leave it like already partway broken down? Do you know what I mean? Right? There's no use in putting it all together if you need to break it all apart anyway to do the ship out. Just leave them separate from the beginning. Break down the 21, 3 times 7. There's this other 3 is there also. You just put them all together in one root. It doesn't matter that they're 2 separate roots. Just throw them all together in one root. 2 3s and a 7. That's the same thing we would have got with 63. If we did multiply them, it would have been okay. It's not wrong. You know, it would have been 7 times 9, and there's the 2 3s and a 7. See, it's the same thing. either way. I'm just saying, you know, don't bother with that. And now, what's in the hook here? Yeah, are we good? Do you know if there's no number in the hook, it's understood 2?
Yeah.
Have we talked about that? I can't remember.
Yeah.
We did. Okay, good. So it's understood 2. So that means it's a 2 for 1 deal. 2 3s in. 1 3 out. They're gone. So what's left on the inside? Just so you don't have to put anything in the hook. If you put nothing, it's understood to be 2. There it is. Is that good? Questions I can answer? So if you get 2 separate roots, just make it 1, is the moral of the story. Just put them all together in 1 root and do the same old thing. All right, try that one. Cube root of 5 times cube root of 25. So right away, just put them all in the same root. Doesn't matter they're in 2 separate roots. Same thing, just put them all in 1 big root. Don't multiply them together, just break them apart, right? Just bring down the 5, break down the 25. Not good? Just lump them all together, 1 big root. So what's the answer going to be? Just plain 5, huh? Because there's 3 5s inside, so 3 for 1 deal. 3 5s in, sends 1 5 out, and they're gone. So what's left over in the root? Nothing. When there's nothing left over in the root, it vanishes. There's nothing to write in there. So it's just plain 5 out of the root. Does that make sense? 3 of them in, so 1 ships out. Nothing left over in the root vanishes. Roots aren't too bad, are they? It's easier than those big fraction questions. Okay, so the square root of 2x cubed, square root of 10x. Okay. What should we do there? Well, just put them all in 1 big root. Just put them all in 1. Let me give you a second to work on. Just put them all in 1 big root. What's in the hook on this one?
2.
2. Understood. Invisible 2. It's the only invisible 2 I know of in math. So there's nothing in the hook.
Two x is second square root, right?
Yeah, that is right. Y'all getting it? So bring down the 2. The 10, you know, is, I'll just put the numbers in the front. Good for the numbers? 2, 2, 5. Now, with the x's, you can do whatever you want. I think the easiest thing is just to put them together and then divide by 2. Because right, you're going to divide by the number in the hook, aren't you? So where'd I get the 4? Well, because this is 1x here and 3x is there. 4x is all together. Is that good so far? So everybody see, because this, I know I'm kind of pausing stuff because I remember students asking me some good questions on the exam in past semesters that has this. It can be a little tricky. So everybody's going to do. I put them together, so I want to make sure you're clear. Putting those x's together first, like that, 4 x's, and then because the reason I do the x's like that is because it's so easy to just divide the power, isn't it? The powers are easy. So there's an understood 2 in the hook. So 2 2's in, 1 2 out. X to the 4th, you just divide the power by 2 because of the 2 in the hook. The understood 2, invisible 2 in the hook. So that's x squared coming out. What's left over? Just the 5, huh? No more x's. There was no remainder in the x division. If that had been like x to the 7th or something, and I divided by 2, that would be 3. 2 goes into 7 3 times. So I would have had x to the 3rd and the outside remainder 1 left in, huh? You okay with how the x power thing's going? You just divide by the number in the hook. Take the x power, divide by the number in the hook, and that's what comes outside. If there's anything left over, that remains in. I'm probably over-explaining it. You've got it. Questions? Kind of a weird one, I think. So it's So it's, let me write it a little bigger. 7th root of 2t to the third times 7th root of 3t. Nothing's coming out, huh? Just lump them together into one big 7th root. And there's not 7 of anything. So nobody's coming out. So what does that mean we do? Just multiply them all together. Yeah, so 2 times 3, is 6, and t to the 4th, and that's just it, huh? There's not 7 of anything, so nothing's coming out. That's just it right there. Kind of a weird question. All good? Everybody see why nothing came out there? All right, so we have the 4th root of 10,000 times the 4th root of 10. What is that? 10 what in that second root? What is that number right here? 10 million, huh? That's million, yeah. So, what does that mean? Think about zeros in the back of a number. What makes that happen? Just think with me for a second on that. 10 times 10 is 100. You see that? So 2 zeros comes from 2 tens, huh? So 10 times 10 is 100 times another 10 is... Yeah, so basically the number of zeros is the number of tens, isn't it? That multiply to make that thing. You with me? So everybody see that pattern? So that means when I look at 10,000, how many zeros there in 10,000? 4 zeros. That means it's 4 tens, really, if I was to break it down with my calculator. You with me? So that's 4 tens. So what? Well, this is a 4 for 1 deal. 4 tens in, what's coming out? A single 10. Now, you might be thinking, I wonder if this is what you're thinking. Wait a minute, so you got to break that all the way down. You got to go down to 2 times 5. Why aren't you doing that? Actually, you don't have to. I know I normally do that, but really, if you see matches at any level, even if it's not all the way broken down, if you see the same old thing, 4 of them, you can ship out right then. You don't have to go all the way down to 2 times 5, 2 times 5. You could. It's not going to, hold on. It's not going to be different. It'll work still, but this way is easier. Does that make sense? Yeah, what you're saying, Renee, is right. If you did break it all the way down, that would be totally correct. Yeah, if you did break it all the way down, it would be 2, 5, 2, 5, 2, 5, 2, 5. It would be 4 2s and 4 5, so out would come a 2, out would come a 5, which is 10. So that's just the harder way. You don't have to do it, but it would be the same either way. Does that make sense? So you can ship stuff out at any level. I know we normally break it all the way down, but you don't have to. If earlier on you see match, just ship it right then. You don't have to keep going all the way down every time. So what about this 10 million number? How many? So everybody good with the first one. The first part is just 10.
There's 7 zeros.
Yeah, how many zeros? Oh yeah, I was thinking there were 8. There's only 7, huh? Oh, yeah. Okay, so there's only 7 zeros. You're right. 1, 2, 3, 4, 5, 6. So there's 7 zeros, which means 7 tens. And so 4 tens in, 1 10 out. 4 for 1 deal. What's left on the inside of the 4th root? The 3 tens, which is 1,000, right? 3 zeros, 1,000.
So would you do 10 times 10?
Yeah, good. So the stuff on the outside, we do have to multiply, huh? 10 times 10 is 100. 4th root of 1,000. There's the answer. Nice show. Everybody see that right there?
You can't cancel out any of these zeros, can you?
No, there's not 4 of them. Yeah, we know we're done there and we're as simplified as we can be because that 1,000 is only 3 zeros, so there's not 4 of anything. That makes sense on that with all the zeros? So basically, again, 10,000 is 4 zeros, so that means it's 4 tens. So 4 tens in, 1 10 out, and that first root completely vanishes because there was nothing left over in the root. It all came out cleanly. The second root had 7 zeros, so the first 4 tens sent a 10 out, but the last 3 tens had to stay in. 1,000 stays in. 10 times 10 on the outside is 100. 4th root of 1,000. So square root of 35a over square root of 7a. What are we supposed to do here? Could we just divide those numbers? Was that what I heard you say, Ajane? Could we do that? Totally. That's a great idea. Yeah, and it's because they're both in roots that we can do it. What I mean is, like if this 7a on the bottom was just a plain 7a, it was not in a root, then we could not do it. They would, and we're going to have some of that in a minute, right? So if they're in different worlds, if one of them's in the root and one of them's out, then yeah, no interaction. But these are both in roots. Totally. A's cancel just like normal. And use your calculator, or if you just off the top of your head, 7 goes into 35 5 times. Yeah, and it's not just the 5, it's the root of 5, and there's still in a root on that. Yeah.
If the 7 did not have an A, could you still?
Yeah, you totally could.
Oh, really?
Yeah. So root of 35a over root of 7, good question. You totally could. 7 goes into 35 5 times. The answer would be root 5a. Yeah, because there's no glue here. There's no plus or minus. It's not Costco shopping. So you can buy just part of it. It is totally fine. That's a good question. So does that make sense? You guys know what I mean, right? If the plus or minuses were there, then we got to be all careful. It's all or nothing. But no, there's no pluses or minuses here. If you wanted to just cancel the 35 part, you totally could. If it didn't have the A, that's fine. It doesn't have to have it all. That would work. Good question. Other questions on that one? We good? Okay, so we have the cube root of 24 over the cube root of 3. So give that a try. Bless you. Can you just divide them? Totally.
Yeah, because
Right.
of the cube root, both cube roots.
They're both in roots. Just go ahead and divide them. So 3 goes into 24 8 times. So take it from there now.
8 breaks down into 2.
Yeah, do one more step.
Two.
One more step on that, right? Then you'll have it.
So the answer's just 2.
Everybody good? Everybody getting that? So 2 times 4, 2 times 2. Mike, racing ahead, you good? So 3 2's on the inside. 1 2. It's over here, huh? 1 2 on the outside. Nothing left in that root, huh? So the root vanishes. Is that okay? Yeah.
Would there ever be like a chance when the hook number changes, or would it always be the same?
Not in this class. No. No change in the hook number.
Save it for next year.
Yeah, maybe calculus or something. Good? We good with that? Then so I just divided them. Then I had the 8, and then out came a 2. Ajane. Glad I could help. All right.
And since it's not a package deal, we can divide, right?
Yeah, we can totally divide this because it's not a package deal. Exactly right. There's no Costco plus and minus stuff here. So you can just cancel anything you want. You have freedom to cancel. There's no glue.
Wow. Well,
So just cancel stuff out, and then whatever's left over,
the
do
lack
the
of
2 for
rules-
1.
Lack of rules is making me feel rebellious.
Okay, so 9 into 63, 7 times. You just calculate for the rest of those. X with X. So we're left with root of 7y. The root from the bottom is totally gone. Everything canceled. So far, so good. And now the y cubed, you know what's going to happen, right? So that's 3y's. What's in the hook on this one?
2.
Yeah, 2 in, 1 out. Out comes a y. In is
Square root 7.
7y.
So
Yeah.
if you kept the 2 in the answer, it would be the same answer?
Oh, if you put the 2 in the hook? I don't know what Math Excel would do. I mean, you're right. Technically, mathematically, it's the same.
So either way is right.
Technically, mathematically, I don't know if Math Excel knows that. It probably does. Let's try. 15 we go.
Although your answer is equivalent to the answer, and it's not in the correct form.
All right, same thing. Start canceling. Just cancel. And then when you're done, do the 3-for-1 ship out. So 5 goes into 40 8 times. And then you subtract powers, huh?
Yeah.
So 8, and you subtract the powers, was that a squared? On that, 7 minus 5, and b to the first, like that. Or just regular b. Good so far. And now, we can do something with that 8, huh? That 8 is 2 times 2 times 2. 2 times 4, or 2, 2, 2. And 3 2's in. It's a 3-for-1 deal. 3 in the hook, 3-for-1 deal. 1, 2 out. They're gone. So 2 on the outside. What's left on the inside? A squared b. And they can't come out because there's not 3 of them. No, there's not 3 A's. There's not 3 B's. Is that good? Questions on that? All right, I'll keep. So let's try that one. So the deal is the 3 on the inside can cancel into the 324. Right, they can interact, but the 3 on the outside's in a different world, and you can't do anything with him, right? Y'all good with that? So 3 goes into 324 108 times. So the first step would be root of 108xy over plane 3. Right, this went in 108 times. Good for the first step. Keep going. Everybody see how I did that first step? Just canceled the insiders with the insiders. The inside stuff with the inside stuff.
So the root disappears because there's nothing inside.
Right, the root from the bottom is gone because there's nothing left in the root from the bottom. And now you got to break that 108 down, right? Over the side of your paper, break down that 108, use your calculator. Find out all the little numbers that multiply together to be 108. So take that 108. And when I look at 108, I don't know what's in there either. I don't just look at it and automatically know what it is. I just know 2 goes in because it ends with an 8. You know what I mean? Just start there. Use your calculator. 2 goes in. Take 108, divide by 2. Get 54. Now you might recognize that one. If not, just divide by 2 again if you're not sure. I recognize that one as 6 times 9. But if you're not sure, just divide by 2. You just keep getting smaller and smaller. And then 2 times 3. 3 times 3, bring this 2 down here. So there's the breakdown of a 108. 2 2's and 3 3's. That's the guts of a 108. So it's not too bad to do that, right? Just divide by 2 for a long time till it breaks down. So what do we got then? Inside the root we have 2 times 2 times 3 times 3 times 3 over 3.
So 2 times 3 goes outside.
What's in the hook? Yeah, there's nothing in the hook. That's right. So this is a 2-for-1 deal, isn't it? Everybody good to there? Oh, I left the x and y off. X and y, huh? Anyway, so now we do the 2-for-1 ship out because there's nothing in the hook. So means 2 for 1. So 2 2's in, 1 2 out, 2 3's in, 1 3 out. And they multiply on the outside just like they were multiplying on the inside, so it'll be 6. What's left inside? 3xy over 3.
Okay,
One more step, huh?
The 6 and 3?
Yeah, because they're both outsiders. And there's no glue anywhere. There's no plus or minus. Don't have to worry about that. Just the outsider with the outsider. 3 into 6, 2 times. So what's the final answer? I'm kind of going all over the place here.
3xy.
2 square root of 3xy. Did you track with all that? That had a lot of different turns in the problem. Everybody see? So from the beginning then, I canceled 3 into 324, right? I divided these because they were both insiders. Got the 108, broke down the 108, 2 2s, 2 and 3 3s, sent out a 2, sent out a 3, 2 for 1 deal. And then lastly, divided the 3 into the 6 because they're both outsiders. Outsiders interact with outsiders. And there it is. Is that good? All right. Okay, so on this one, same kind of thing. So start canceling stuff. I would just start canceling. It'll get a lot nicer when you cancel. 810 divided by 10, that just cuts off the 0, huh? Just makes it 81. Question?
Could you cancel out numbers if the square roots have different hook numbers?
No, they won't do that to us. They won't mix hook numbers on us. No, none of that. Those would be really hard. That'd be like pre-calc or calc or something.
But that is a thing.
Sure, I mean it's possible. Yeah, they won't throw it at us. Yeah, no, it is. Yeah, real life, and they do things that happens. It's true, but it's really ugly. We don't want to go there. 10 into 810, 81 times. That good? Just cuts off the 0 there. So 4 through to 81. And then with the x's and the y's, you just subtract the powers, right? So it's x to the 21 minus x to the first to be x to the 20th. Y to the 17 minus y to the 8th, what is that? Y to the 8th? How we doing? Good so far. I just divided. Inside stuff with inside stuff. Okay, now, break down that 81. Now it's 4 for 1 deal time. 4 for 1 deal. Break down that 81, do a 4 for 1 chip out. Break down the, or you can just, and divide both those powers by 4, right? So 81 is 9 times 9. So broke down. That times 9, 3, 3, 3, 3. So 4 3s in, 1 3 out. Whoops. And then what about the x's? What do you do for the x's and the y's? You divide them by the hook number. So divide by 4. Divide by 4. That's what comes out. So that would be what? X to the 5th. Y to the 2nd. What's left in the... Oh, nothing? Yeah, there's nothing left in the hook. I don't need to make the hook again. That's just it. Nothing's left in the hook, huh? There was no leftovers. Everything perfectly came out. Is that good? Questions on that? So everybody getting the hang of you divide the powers by the hook number, don't you? And if there's any remainder, like if 4 didn't go cleanly into 20, if there's any remainder, that remains in the hook. Oh, from the beginning? Totally. Yeah, like x to the 21 over x, you go 21 minus 1. Yeah, remember that rule of you can subtract powers, yeah. And why that is, that's because they're canceling, really. One of the 21 x's from the top cancels with the one on the bottom, leaving 20 on the top. That's what that is. You subtract the powers. Good. Let me explain. The cube root of 343 over 216. You can't reduce that at all, right? Nothing goes into 343 and 216. right? They're not both divisible by 2 or anything. You can't reduce the fraction. So what do? I would just do the cube root of 343. I would use my calculator. I would just take that 343. Well, if you have the cube root button, you can do that. Let me just show you by hand. Take that 343. What goes into 343? I don't know. Oh, is it 7? Oh, yeah, you're right. Divide. So if you divide by 7, you'll find it's 7 times 49. Tracking with me? So you just got to try different numbers in your calculator. Just take that 343, try divide by 2. Well, obviously 2 doesn't go in. Divide by 3, divide by 4, 5, 6, 7. You'll find that 7 goes in. 7 times 49, and then 49 is 7 times 7. Is that good? So what does that mean then? 343 is 3 7s. So the 343 on the top stuff comes out on the top, bottom stuff comes out on the bottom. 343 on the top is going to send 1 7 out to the top, right? Because it's a 3 for 1 deal. 3 7s in, 1 7 out on the top. And now on the bottom, 216. Take your calculator. Now I know 2 goes into that. 2 times 108. I'm going to need some more room over here. So it's going to break down a lot. 216. 2 times 108. 2 times 54. 6 times 9. 2 times 3. 3 times 3. So there's the breakdown of that 216. Look what we got here. 3 2s and 3 3s. You with me? 3 2s, send a 2 out. 3 3s, send a 3 out. We've got a 6 on the bottom, 7, 6. We're done. It's okay to leave the top bigger than the bottom. That's fine. As long as there's nothing you can divide. Nothing goes into 7 and 6, so that's good. That's simplified. There it is. Did I lose you on that one? That okay? So I broke down the 343. I just tried dividing by numbers, found out 7 went in, 49. Used calculator. 3 7s in, 1 7 out on the top. For the bottom, I broke down the 216. Came out to be 3 2s and 3 3s. So out came a 2, out came a 3. For a 3 for 1 deal. Right? Because that roots over the top and the bottom, which is 6. No, because everything left the root. Yeah, so there's nothing left in the root. They all came out. There's no remainders. All right. I think the next section's fairly large too. All right, so... All right, let me give you a second. Maybe you'll get more out of it. Try that one. Okay, what's the answer? Square root of 100? Square root of y squared? Done. That make sense? It's just square root. It's just normal square root, huh? Square root of 100 is just 10. This is 2 y's in, 1 y, right? There's nothing in the hook, which means 2. 2 y's on the bottom, 2 y's in, 1 y out. Now here's a common mistake that I've seen people make in the past, and I don't want you to make, so I want to show you so it won't get you. Here's a typical answer. They'll have like 10y. That's not right, huh? Because they're trying to trick you. That y on the y squared on the bottom, when the y comes out, it must stay on the bottom. It's not 10y, it's 10 over y, huh? Is that good? Not to be tricked by that. So just remember, top stuff stays top, bottom stuff stays bottom when they come out of the root. Good? So you won't be tricked by that? All right, so we have the square root, 64y to the 7th, over x to the 10th. What's in the hook?
2.
All right, I'll give you a second, see what you can do with that one. you know, you don't have to do anything fancy with that 64. You could just say, what's the square root of 64? It's just 8, huh? You don't have to do a bunch of, if you recognize the root, you don't have to do a bunch of fancy stuff. Square root of 64 is 8. I mean, you could break it all down and it'll be 8 eventually. So I would just go 8. That's square root of 64. Now do the letters. And remember, the y stuff's going to come out on the top and the x stuff on the bottom. That never changes.
But there's stuff on the outside. Or inside.
So what's in the hook is a 2. So remember, you divide the powers both by 2. Is that good? Remember, that's how we always handle powers, right? We divide by the number that's in the hook. Understood? 2 in the hook. Is that good? Is that good? So what? Let's finish.
I'm amazed I'm getting very happy.
All right. So on the bottom, x to the 5th. No root on the bottom. Everything came out. Is that okay? If you're not, you know what I would do, guys and gals, on the test? If you're doing this and you're just not sure, it's a, like test, you know, and you're not sure which to bubble and your grade's on the line, just write them out. You know, you don't have to do the shortcut. If you're unsure, just write them out. Was it 6, 7, 8, 9, 10? So just go, okay, look, 10 x's, and it's a 2 in the hook. So 2, send out 1, 2, send out 1, 2, send out 1, 2, send out 1, 2, send out 1. Yeah, 5 come out, nothing left over, huh? No remainder, so no root on the bottom. There will be a root left over on the top, but not on the bottom. Good. So if you're ever unsure, just write them out and do it longhand. It's a 2-for-1 deal at Target. 10 X's on sale, 2 for 1. You're going to pay for 5, right? On the top, 7 Y's on sale, 2 for 1. What's that mean? Well, 2 goes into 7 here. That's what that means, written backwards, huh? 2 goes into 7 3 times. There's 3 groups of 2. 1 remainder. So 3 groups are coming out. 1 remains in.
That where you put it right next to it like that,
Or what else?
or would you just put more like in the middle of that?
I gotcha. Do you mean, Car, do you mean kind of like that?
Yeah.
Good question. Both are right. Either way is good. Yeah. Remember, to be out front is the same thing as to be on top because you're over 1. Anything alone is over 1. So it's the same as being on top. That's good, though, because sometimes they do the multiple choice answers that way, huh? And you can be like, I don't know, that's the same as what I have? So that's a good question. So everybody know, if they put that root y in the front, yeah, and especially with roots they do that. That's the same answer, isn't it? Because remember the rule that to be alone is to be in the top, because you're over 1, really. You are a numerator thing, right? Anything alone is over 1, really. Right? That's not a new concept. We've done that before. Anything alone is over 1. So anything alone, it's the same as being in the top. So you could write it like that, in the top, or you could just stick that root y in the front middle. That's the same thing. Is that okay? Now, if you're looking at these y's and this dividing thing, and you're like, I don't know, I don't feel that comfortable, it's okay. Just write out 7 y's. Let me just show it again from this way. You just look, I'm going to write 7 y's. 2 for 1. 2 y's. Sends out a y, 2 y's sends out a y, 2 y's sends out a y. So y cubed on the outside, 1 left over on the inside. And we're done. Is that good? Comfortable with those root rules?
Sure. You're the one that gets to assign how many questions we have.
It's true. But then I'm disappointed later with how much we can't get through it all so much. Okay. So I would just make those 2 separate. You don't have to, but it's all the same thing. It's all good. I'll just make it root on the top, root on the bottom, same thing. 1 big root, 2 separate roots, all the same thing. Okay, so you know what to do, right? Break that 32 down with the factor tree. Break down that 32 with the factor tree, and 5 for 1 deal. And then for the powers, you divide by 5, don't you? Or you can write them out. If you're not sure, just go ahead and write out 20 y's and 8 x's and do a 5 for 1 deal. But the effect is it'll divide by 5. Break down that 32. We've seen 32 once today already. Remember, he's 5 2s.
Oh.
That's convenient. He's 5 2s. So 5 2s in. 1 2 out on the top, right? Because the 32 came from the top. So 1 2 outside on the top. Now the rest is letters.
32, okay.
So take the letter powers and divide by 5. So we'll divide by 5, divide by 5. So 8 divided by 5, 5 goes into 8. 5 goes into 8 one time, remainder 3. You with me? So 1x on the outside, 3 remaining on the inside. I got to keep the 5 in the hook. To see how the top works? Is that okay? Again, if that's confusing, then just write 8 x's and do it the long way. 4, 5, 6, 7, 8. So 5, it's 5 for 1 deal. 5 x's in, 1 out, excuse me, and 3 remain inside. That's the top, it's the numerator. Bottom's easier, huh? The bottom, you just divide 20 divided by 5 is 4. Y to the 4th. 4 groups of y's coming out. That's it. There's nothing more we can do with that. It's getting easy. Getting kind of the same every time. Break down the numbers, divide the powers by the hook number. Some stuff comes out, some stuff remains in. Yeah, I really think the root chapter is a little bit easier than the... And